Okay, so you should have written this down already and attempted this problem. So what did you find for the values of each shape? So the way you want to look at that is that this is a balance. So if 60 is being split right here, 60 is being split in half, then each side is going to be 30. So knowing that this side is 30 but having three different shapes doesn't help me a lot. So then I have to keep looking and say, well, now 30 is being split in half because this is going to be balanced. So I know this side is 15 and this side is 15. So now the middle strand does tell us something, because if I have three triangles that are equal to 15, doesn't that mean each triangle is 5? And if this triangle is 5, doesn't it tell me that the green square must be 10? And if I know that triangle is 5, square is 10, together that's 15, so the circle must also be 15 to equal 30. So hopefully you came up with that. The reason we started with that is today we're starting to solve systems. So this is a picture, but it is a system of equations without really knowing that it is, right? We're going to look at a couple more things that are pictures. So if I look at this situation, can you figure out what the weight of one box of tea is and what the weight of one box of salt is? So if I look at this right here, that's not enough information. I need this other stuff on the right side, that when I look and see that 4 salts weigh 12 pounds, doesn't that tell me that 1 salt must be 12 divided by 4, or 3 pounds? So now if I know that these are 3, 3, 3, in salt, don't I have 9? So if I subtract 11 minus 9, that leaves 2 for the 2 T's. So isn't each T 1? Okay, take a look at this one. I want to know the cost of one notepad and how many pens does that equal? Well, if you start looking at this, and both of these purchases cost me $21. So I start to look at what is common to them. So if I look at this, I've got one notebook, two notebooks, one notebook, two notebooks. I've got one pen here and one pen here. So doesn't this leave one notebook over here equal to 2 pens? So what we've got to do is eliminate things from both sides if they are equal to each other to get down to the simplest form. If I look at this one, now we're looking at some food and how many calories it adds up to. Okay, so look at this. We know a couple of things, right? We want to know how many calories in one pizza and one bowl of snacks, what their total is. Well, so this number of calories is less than this number of calories. You can see that I've got a pizza and a bowl of snacks, a pizza and a bowl of snacks. So if those two things are equal, and I take that out of here, the pizza by itself and the snacks by itself have to balance out the rest of it. So isn't the pizza have to be whatever the bowl of snacks is plus 100? Okay. So that's what I'm looking for there. Okay, so where are we headed with this? We did both those by pictures. What we're trying to be able to do is take that same kind of information, turn it into equations, and figure out the things like we were just doing without having to draw pictures of, pizzas and things, but solve it mathematically. So look at this problem. Your family opens a bed and breakfast. They spend $600 preparing a room to rent. The cost of your family for food and utilities is $15 per night. They charge $75 to rent the bedroom. Okay, so if you look at this, hang on, let me get some power in here. Okay, if you look at this, we want to write an equation that represents the cost. So I'm going to use C to represent cost, and it's equal to $15 per night times the number of nights. That comes from this information right here. That's food and utilities for that room. So I'm going to say is equal to $15 times how many nights, and then the initial $600 that was spent to get that room ready. The income from that, right, is called revenue. And the revenue that your family is getting is the $75 per night. So if it is, as we look at down below, we're going to look at what each of those is for a night. So use the cost and the revenue equations from that we wrote above to figure out how many nights your family needs to rent the bedroom before recovering the cost of preparing the bedroom. That's going to be our break-even point. So if I look at my revenue, if I have somebody staying there, that's my X number of nights. So 0 nights, I'm not going to make any money. 75 times 0 is 0. If I have somebody staying there 1 night, I'm going to make that $75. Staying 2 nights, it's going to be 75 times 2, so 150. Let's look at the cost equation. So the cost equation for 0 nights means that this X is 0. 15 times 0 is 0. So it's still going to cost me $600 to have gotten that room ready, even before anyone stays there. After the first night, it's going to cost me $15 in addition to the 600, so $615. After 2 nights, 15 times 2 is 30, plus 600 is 630. If I went and kept multiplying these out, I would come up with all of those numbers. So the question is, how many nights does your family need to rent the bedroom before you break even? Well, you're going to break even when the amount you spent is equal to the amount coming in. So you can see by looking at our table that right here, the amount going out and the amount coming in is the same. It's $750. So it would take us 10 nights to recoup the money that we had spent as income. Okay, let's take this a little further. So if you remember the revenue equation we had, the revenue was y equals 75 times x, and the cost equation was y equals 15x plus 600. If I go ahead and graph these, and for the speed of it, I've already graphed them. If I look at this, the red one is going to come in here and has to start at 600. And then is going up 15 dollars each number of nights. Okay, if I bring in the revenue equation, starts right at 0, and it's going 75 up each night. So I'm going to find that the place these intersect is right here. So if you look at this, the number of nights is 10. And the dollar amount where that is happening is 750. So the intersection point of the two graphs is 10 on the x and 750 on the y. And how does that compare to the break-even point we came to before? Well, that's exactly the same. So what we're looking at is that we can use the intersection of these two graphs to find the point that makes both of them true at once. Okay, I'm going to start a new video so that it's not too long. So come back to the next video.